Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The substrate is 1-bromo-1-methylcyclohexane, a tertiary alkyl bromide. Solvolysis with water proceeds via an SN1 mechanism. The rate-determining step is ionization to form a tertiary carbocation intermediate, followed by attack of water as nucleophile and deprotonation. Moving on to the next step. The starting material is a single enantiomer, CH3 on wedge, Br on dash. The products are both enantiomers of 1-methylcyclohexane, 1-ol in equal amounts, racemization. This is consistent with formation of a planar carbocation intermediate that is attacked from both faces with equal probability. Moving on to the next step. An SN1 reaction has two transition states and one intermediate, the carbocation. The first transition state, ionization, CBr bond breaking, is the highest energy point because ionization of a CBr bond is the rate-determining step and requires the most energy. The carbocation intermediate sits in an energy well between the two transition states. The second transition state, nucleophilic attack by water, is lower in energy than the first because attack on a carbocation by water is facile. The overall reaction is exergonic. Products are lower in energy than reactants because the bromide leaves and a stable alcohol is formed. And for the final step, the correct diagram must show I, the first, leftmost, transition state as the global maximum, 2, a carbocation intermediate in a shallow well below it, 3, a second transition state lower than the first, and 4, products lower in energy than starting materials. Diagram B matches all these features. The first peak is the highest, there is an intermediate, the second peak is lower than the first, and the products end up lower than the starting material. A shows the second transition state lower than the first but the products are lower than in B, and the intermediate appears very stable. Possible misrepresentation of the energetics, more critically in A, the profile shape suggests a different energy ordering. C shows the second transition state higher than the first, which is incorrect for SN1 since nucleophilic attack on a carbocation has a lower barrier than ionization. D shows products higher in energy than starting materials, which is incorrect since solvolysis of a tertiary alkyl bromide to an alcohol is thermodynamically favorable. Therefore, the correct answer is B. Therefore, the correct answer is option B.